Now let's connect an output to an input and observe the displays and see how we can measure some parameters. Let's start with the simplest output, the plus-minus 5-volt power supplies, and measure them with the voltmeter. Before we start the instruments, let's make the actual physical connections with the appropriate leads from the 30-pin connector on the ADM. To make connections between the leads, we can use the header pins that were supplied with your ADM. If you need some, or you've lost them, just ask any of our lab engineers in 2C94 for some more. Connect the leads as shown here in this picture, with the V plus connected to the 1 plus, the V minus connected to the 2 plus, and the 1 minus and 2 minus both connected to the ground, or black wires. Now we can start the waveform software again, and from the main window, launch the power supplies and the voltmeter. Arrange them on the screen so you can see both of them at the same time. Click Run on the voltmeter if it isn't already running, and click the Master Enable on the power supplies. Both supplies should now show as on. If not, just turn them on by clicking the individual controls. Since we are only dealing with direct current supplies, we can deselect the plot checkboxes for the AC measurements in lines 2, 3, 5, and 6 to declutter the display at the right. Click the settings icon in row 1 and deselect Auto. Then set the range to 2 volts per division and the offset to 0 volts. Do the same for channel 2. You should now see channel 1 reading approximately a plus 5 volts and channel 2 reading a minus 5 volts, along with the corresponding color-coded plots on the right. Turn the plus 5 and the minus 5 volt supplies off and then back on again to verify that the value displayed and the plot respond accordingly. Note, it may take several seconds for the voltage to drain once the supply is turned off. Another note, if you click the settings icon for the display, you can change the update speed so that your display will update a little bit faster and produce a smoother plot. Now, let's change the output source from the power supply to the wave generator. Close the power supply window and open the WaveGen window. Remove the V plus and V minus leads from the header pins and connect the W1 and W2 leads to the voltmeter input instead. The ground connections that you will need for the generator output are still left from the supplies connection. Your connections should now look like this. Click on the channels pull down and start channel 2 and select Basic for the parameter options and click Run All. Now select DC for the type on both channels. You'll notice an offset slider with limit windows at the top and the bottom. Change the top limit to plus 5 and the bottom limit to minus 5 for both channels. Type 2.5V in the channel 1 offset window and a minus 2.5V in the channel 2 window. Note the DC readings in the displays on the voltmeter. Slowly adjust the offset sliders on the WaveGen and observe the corresponding change on the voltmeter. Since the oscilloscope input leads are the same as the voltmeter, all we have to do now is close the voltmeter window and open the scope window to use these inputs. Again, resize and reposition the windows so you can see both instruments on your screen. Adjust the range for both channel 1 and channel 2 to 1 volt per division so each channel can display plus or minus 5 volts. Click Run on the scope window and you should now see the DC voltages from the wave generator displayed as straight lines on the scope display. On the WaveGen, select the sine wave for the type in both channels. The default frequency will be 1 kHz or 1000 Hz, and the default amplitude will be 1 volt. Each channel will inherit the offset that you set in the previous step. If your offset was more than about 1 volt for channel 1, you'll notice the display is not stable and appears to jump around randomly in the horizontal direction. This is the triggering issue referred to before. With the default values for triggering, the scope never sees the channel 1 level rise through the 0 volt threshold that is set by default. There are two ways to correct this. Either select the voltage in the level pull-down within the range of the channel 1 signal, or simply move the yellow triangle on the right side of the display until the trigger level is within the signal range. Note the selected trigger level is displayed in the level box in either case. If you change the trigger source to channel 2, you'll notice the triangle now matches the color of the channel 2 trace, or probably blue. You may now have to adjust the trigger level to be within the channel 2 signal range for the display to stabilize. On the WaveGen, now change the amplitude of channel 1 to 4 volts and the offset for channel 1 to 0 volts. On the scope, deselect the channel 2 display and change the time base to 0.2 milliseconds per division to now only display the channel 1 sine wave. Note that in the upper right corner of the display, if you click on the Y once, it will place a cursor and cursor line on the screen. Click a second time to add a second cursor line. If required, move the first cursor line to correspond to the bottom of the sine wave trough. Now move the second cursor line to match the top of the sine wave. Note that the second cursor box shows 2 delta 1, and the value shown on that line is the difference between the levels at cursor 1 and cursor 2. In the bottom left of the display, there's a similar X cursor box. Again, click twice to place 2 vertical cursor lines on the display. Move the first one to a point where the sine wave crosses the 0 volt level, and then move the second one to a similar point to the right. Notice that this second cursor is also a delta measurement and shows the time difference between the two cursors. Note that the time required for one full cycle, i.e. back to the same point in the wave as it started from, is approximately 1 millisecond, which is exactly the time required for one full cycle at the 1000 cycles sine wave that we're displaying. The small triangles on the lower right of the cursor boxes will open a dialog box that will let you control their settings. You will find the cursors a very handy feature for measuring and analyzing properties. One final feature of the scope that can be very handy is the Add Channel button. The Add Channel button will add an additional trace to the screen. For instance, if channel 1 was measuring the voltage across a 100 ohm resistor in your circuit, and you wanted to show the current through this resistor directly on the display, I can add a custom math channel. Clicking in the formula box, another dialog opens where I can put in the formula C1/100, or channel 1 divided by 100. Clicking the setup icon in this channel as well, I can select A, or amps, for the units. And finally, if I set the range for this channel to 0.02 amps per division, or 20 milliamps per division, it will display current directly on the vertical axis when the channel is active. This has been a quick overview of the ADM and the associated Waveforms 3 software for Macintosh. You will discover many more useful features as you use these to explore electrical concepts through the lab assignments in this course. Remember to use the built-in help feature to help you discover more uses and to use the different features of these devices.